Hey, welcome back, you guys. Thanks again for joining me on my channel and solving this video shot algorithm. So this is going to be part two. If you haven't checked out part one, we talk about how to build our algorithm and how to go step by step to get to the programming part. And this is the programming part. So last time we were here, we outlined the problem, and the first step that we were trying to figure out was how do we find the duplicate and where does it occur? What is the highest index where it occurs in the array? Let's take a look at some code right now. So if you look at the code here, I've set it up so that we have the three different cases here. The first case is the one that I showed you in the PowerPoint slide. The second case is one where there are no duplicates, and then the third case is where there is a duplicate, but the duplicate occurs at the end. And there are a lot more use cases, and just trust me on this, it's going to work as long as we write it out the way that we're going to write it out right now. Obviously, I'm not saying that I'm perfect, but this solution I've tried and tested, so don't worry about it. It does work. So what I did is I created a C# project using Visual Studio. Those of you that are not familiar with C#, I've said in the first video that my language of preference is C#. So all the examples that I'm going to do, and as you see my YouTube channel, is all .NET, Microsoft. I don't think it matters if you use Python or C++. You can probably translate this back to another language and it should be fine. So let's look at what I want to kind of go back is to our PowerPoint slide as to what we were looking at with the movie shot. So this use case is the one that I've outlined in the video shot array here. Okay, so it's the list of strings. So this one right here is the one that we took a look at over here. Okay, now what I have not shown you is the actual wording of the problem as you would see it on any platform. So let me go to that real quick and we can take a look at that together. I don't want to spend too much time on it, but you can see just how confusing it can get. Okay, so let me do that. So if we take a look at the original problem here, you can kind of glance at it a bit. The input that is coming in is going to be this input list, and if we take a look at our code, usually what they'll do is already give you this all set up so that it just reads it in. I actually wrote it out as I hard-coded the array just so I can show you how it's populated. Okay, so this is the first example, second, and then third, and then the movie shots function is probably something that they will already give you with something that's going to be returned back. And that's actually what they are asking for, is they're giving you this list. It could be an array, it could be a list, and they give you a little bit of an explanation as to why the output is what you're getting. So for this, you're getting 9, 7, and 8 because according to what we went over on the first video, you know that the first 9 shots have the duplicates, and then in the second segment, there's 7 shots without any of the shots that occur in the first 9, and then after that you have 8 shots in the third segment, which have shots that do not occur in the previous segments. And the examples that they show you here are, they're going to give you an input, then the output. This is 1, 1, 1 because again there is no segment where A is repeated after the first element, neither with B, neither with C. So if you show these in a segmentation array, then it's correct, right? There's no repeats in this scene, in this scene, or in this scene. And then the last example is they give you a list where the duplication occurs on the last element, and then there's nothing else to look at. And this would give you a 4 because in this specific shot you can only have one shot with four scenes, or one scene with 4 shots in them. Okay, and then they give you an explanation. Because A appears more than once, everything between the first and last appearance of A must be in the same list, right? So it gives you the 4 as the number of shots for this segment. If you need more background, I mean, I recommend you look at the first video where we go through this step by step, and you can even look at some pictures of myself when I went to Hawaii as well. Just a little Easter egg in there. Okay, so we have this set up as a list in our code, and I'm doing three calls to this function. So if I was to start this off, I know that I'm getting the list, right? And the first thing I'm going to do is, just because I don't like this little red underline, I know what am I going to return. So you're returning a list of integers, right? So in this particular case, we are returning a list of integers. So just to make it simple, I'm going to just say list int. We'll just say scenes is equal to new list, and then I'll just return scenes. Okay, so that kind of takes care of that. We know that we are going to return the scenes in there so that we indicate how many shots are in each scene. Okay, so and it's going to be a dynamic list because you don't know, right? You're not going to know how many segments in terms of a fixed size, right? So the array could be as big as 20 plus, or it could be 3, or it could be 1, it could be 4 elements. But in the mixture of these elements, you don't know what the final output array is going to be. So when you see anything that's dynamic that you're going to return back, you obviously want to use some type of dynamic list. In C#, list a list of ints that's dynamic, so we have no problems there. So as we talked about in the last video, the logic that we want to go with is we want to find where the duplicate is and then catch up to that duplicate. So for example, we can see that A, the latest duplicate, is all the way over here, right? Then B, the latest duplicate, is somewhere here, so we know that A is still the target that we want to reach. So whoever is the largest, the most farthest out duplicate is the target we want to reach until we reach that target, and that's going to be our segment. Now, the first step that we need to do is find a data structure that will store this information, right? It's going to store the letters, right? Because they are all unique in some aspects, right? And one aspect is they're unique in that we have a finite set amount of shots that are identified by a label, but they can duplicate within the array. Okay, so we definitely need to loop through the array to find to add up where the duplicates occur. Okay, so I think that will be the first step that we go through, where we want to iterate through the array and see where the last duplicate of A is, the last duplicate of B is, the last duplicate of C is, and so forth. Okay, so we can do it that way, and we can go do one pass, and we definitely don't want to look back. right? Because if we start counting and looking back, then that falls into O of n squared territory. And those of you that aren't familiar with time complexity, you don't want to, you never want to have, you try not to have inner loops, right? Because inner loops are a man's not best friend. So maybe if we loop, we're trying to find with these problems, okay, so now some of them are unavoidable. Sometimes you're just going to have to do inner loops as kind of like your first draft. But in this particular case, what we want to do is we want to do one pass and find where the last duplicate is. Okay, so is there a way that you can tell me where the last duplicate occurs? So think about occurrence, right? Where does the last duplicate occur for A? Well, in array terms, right, if we go back to our array here, the last duplicate of A occurs at index 8. The last duplicate of B occurs at index 5. The last duplicate of C occurs at index 7. So if you're getting kind of the gist of it, we want to use some type of hash table or dictionary where we can keep the letter and the last occurrence, okay, the last occurrence of that letter. So in our particular cases, for A, the last occurrence of that letter is going to be, you're going to have kind of a, so let me write in here a little bit, insert, a text box. So for A, the last occurrence of A is going to be in the 8th element. Then for B, the last occurrence of B is going to be in the 5th element. Okay, and then C, the last occurrence of C is going to be in the 7th element, right? And so on. And we're going to go up to whatever unique labels that we have, and so on, right? So we need something that can give us a combination of the label and then where the last duplicate occurs. So in this case, I would say the last duplicate, right? So if we take a look at our code, okay, we have our scene. So that obviously we're not going to use a list, because in a list you can only store one thing. What I like using is either a hash table, okay, because the hash table is quick to retrieve, or a dictionary, which is pretty much built upon a hash table as well. So, but it has those key value pairs as well. So what we'll do is we're going to declare a dictionary with a string int, okay, and we'll call this our oops. Okay, so new dictionary string int. Okay, so this is going to keep that list that we were talking about, where, and if we go back to the PowerPoint, it's going to keep the label and then where the last duplicate is. But we won't know where that last duplicate until we iterate through the whole array. So we're going to do a forward, kind of like a forward search. And if we go back, obviously we need to loop through our list. So we're going to loop through the shots. So we're going to say for int I is equal to 0, I is less than shots.count. Okay, I++. This gives us the ability to loop through our shots list here. And what we can do is, if we go back, if our dictionary contains a key, right, which is our keys are going to be our labels, our letters, then we will assign the highest element, the element that we're at, as the value. Okay, so on the first iteration, right, when we start at A, the key, so let's just do this, we don't have any. let's make believe this is our hash table, right? Our hash table, our dictionary is empty. I'm sorry, I keep saying hash table. Our dictionary right now is empty. Okay, we come across this letter here. Are there any A's in my dictionary? No. Okay, so we're gonna add it to our dictionary, and then we're also going to add the occurrence of where that A occurs. Okay, then we go to the next one, which is B, and we check, is B in our dictionary? No, it's not. So we're going to add it, and then we're also going to add the occurrence of that B, so it'd be 1. Okay, then we go to A, which is the second element here. Is A in our dictionary? Actually, yes it is. But the occurrence index is going to be now 2, so we're going to replace this. Okay, sorry, we're going to replace this with 2. Okay, so now we're over here. Then we go to B, and we're going to replace this with 3, right? Because our occurrence is now 3. Then we go to C. Okay, so C is not in our dictionary, so we can say that C is occurrence is 4. Okay, then we go to B again, and we're gonna update this to now, instead of 3, you're gonna do it 5, because that's the highest occurrence of that duplicate. Okay, and then eventually we're gonna get to a point where, you know, A will convert itself to A, right, which will be where the highest duplicate is, and all the other letters will fall in line. So we can say that if, okay, dupes dot contains our key, which is going to be our shots of I. Okay, sorry, this should be this way. So what I'm doing here is I am checking if our dictionary has our key, right? So if somewhere along the line we looped and we found D, is D in our dictionary? That is what this line is doing. Okay, if it's in our dictionary, we want to update the current value, right, which is the index, to where we're currently at, right? Just like we did with A, right? We kept updating it. So what we can say is that take the dupes current key, which is going to be shots of I, and make that where we're currently at. So the I is what we're looking at. If we go back, what we're looking at in the index, right? I is where we're currently at, right? So let's trace this back a bit, okay? So this is our dictionary right now. Our dictionary contains nothing. We start out, right? Is this in our dictionary? No, it's not, right? So we're going to say that A is now 0. Okay, so we need to know it's not here. So no, it's not would say that we want to add shots of I, right? I. So what we're doing here is really what we just did right now, right? Then we go to B. B is now 1, right? Doesn't contain the key, so we want to add, right? Because shots of I, remember shots of I is, shots is this whole array. So shots of I is going to be added to my dupes dictionary, right? Which is what we call it here, right? When eventually we run into one that has the key already, so we run into this letter, right? We have that key, so this is true, right? We take whatever index we're at, which is the number 2, and we replace it in our dictionary. So we're taking I, which is 2, and in our dictionary, dupes, right, of shots of I, right, which is in this case is going to be A. Okay, and as we do that, eventually we're gonna, and we're doing only forward passing. Okay, we're doing forward pass. We're not going backwards. We're not looking anywhere back to find our latest duplicates, right? We're eventually going to populate our dupes array, dictionary. We're going to populate the dupes dictionary with the unique labels, right? And each unique label will have the value, okay? So let me debug this and you can see what's going to happen after the first pass. Okay, so I think that'll be important. So let me debug this. I'll put a breakpoint here and let's take a look. So as we're looking at the dupes dictionary here, okay, I put a breakpoint right after the loop, right? It went through it once, right? So as we're going through the loop, you're doing n, right? O of n, because you're only going through it once. Now, obviously, that's not the answer because you still need to count the segments, right? But at least at this point, once we did the whole list, right? You see here that we have 8 as where the last duplicate occurs, 5, 7, then this one has the 14th element. Okay, so I have now my dictionary with the labels for the shots and where the last duplicate occurs. And we did this all in one pass. And now we're ready to go through the list again, where we can now find where we can segment. Okay, where we can segment. And that's actually, this is the most tricky part. Okay, it's the segmentation. Okay, where do I do my shots, right? Because for the first, if we go back to the problem, for this sequence, the output should be 9, 7, and 8, right? Where the first sequence is going to have 9 shots, then 7 shots, and 8 shots. So stay tuned for the next video, and I will show you what we need to do to get to the final list. Okay, so stay tuned. But at least now you have the first part. Hopefully you can think about this and find the second part. So I will see you in the next video.